Consider this grayscale image. Now this image is made of pixels. This particular one has 3 by 5, so it has 15 pixels. So it's quite a small image. Now each pixel has a value, and that's what defines the intensity of the gray color for each pixel. So in reality these are numbers, but our computer display shows them in a color format, which is easy readable by us humans. Where I'm trying to get is that programs use numbers to store images. Then the computer display, or so the screen, converts these numbers to colors. Python can also do image processing, just like Photoshop does. Probably it cannot do all the cool stuff that you can do with Photoshop, but you can make use of Python to automate things. For instance, we'll be using the image processing capabilities of Python to detect faces from photos, from images, and also detect moving objects in videos as well. So videos are made of images, so it's the same thing basically. And Python stores and reads images using arrays of numbers. For instance, this image could be represented as, a list of 3 other lists. So 3 lists because we have 3 rows there with pixels, and then in each of the lists you'd have like 5 numbers, and so on and so on, and the 5th, and the same for the other 2 lists. We've got 5 numbers because we have 5 columns, so 5 pixels for each row, and that's an image for Python. And here is where Numpy comes in handy. So while you can represent images with lists as we did here, this is not very efficient because for big images, lists occupy lots of memory and therefore they slow down operations on them. So this is solved by Numpy, which is a Python library that provides a multi-dimensional array object. So let me go ahead and create this array object. First of all, what you need to do is you need to import Numpy, and if you have installed pandas, Numpy should have been installed with pandas because pandas is based on Numpy. If you haven't installed Numpy just yet, just go ahead and pip install Numpy. And if for some reason you have some problems on Windows, then just go ahead, as I've showed you, and find the precompiled Python libraries. Go to this side and then search for Numpy. And then figure out if you're on a 3.5 version of Python, then just get that version. And then you point to this file with pip install and the name of the file. Great. Now I have Numpy installed, so I'll create this multi-dimensional object and store it in the n variable. And that would be numpy.arange, and let's say 27. Execute that and print out n. So this is a Numpy array. That's how it is called. This particular one is not exactly a multi-dimensional array because it only has 1 dimension. So it's like a plain list, a Python list, but still it's not exactly a list type. Sorry. So it's a Numpy n-dimensional array. It can have 1 dimensional, 2 or 3. So we have 1, 2, 3, and I'll show all these scenarios. So that was the 1-dimensional array, and if you want to print it in a nice form, and that would be the array. Now I'm just creating a Numpy array using numbers on the fly here, but normally you'd have to create arrays from images, and we'll do that in just a bit. So for now, let's create some arrays manually. Now let's see what a 2-dimensional array is. Shape 3 by 9. So we already have this 1-dimensional array, and we want to convert it to a 2-dimensional array. If you execute that, you get a 2-dimensional array. So that's a 2-dimensional array because it has 2 dimensions. So think of it as this image file, we have two dimensions, vertical and horizontal. Now, what's a three-dimensional array? Even though three-dimensional arrays are less frequently used, it's still good to know about them. And yeah, let me create a three-dimensional array. I could say 3 by 3 by 3, because you know you have 27 elements, so 3 by 3 by 3 gives you 27. And yep, that's a three-dimensional array. Think of that as a cube that has 3 dimensions, so 3 by 3 by 3. And practically you'll see that in just a bit in this lecture. Where do we deal with three-dimensional array? So bear with me. And yeah, you're able to see the similarities between a Numpy array and a plain Python list of lists. So this here would be like a two-dimensional array, if you like to call it like that. Yet the structure in the low level is different between Python lists and Numpy arrays. And also Numpy arrays allow you to make some more efficient operations such as iteration between the array items and so on. And you can also create Numpy array out of Python lists. For instance, I'll get this list here and I'll create a new object and then point to Numpy. And to convert a list to a Numpy array, you'd want to use as array method. And then between the brackets goes the object that you want to convert. And that's an array, which is almost exactly like this one in here. And if you print that, you wouldn't be able to see the difference. You know, they look exactly the same. But they are not, because this is a list and this is a Numpy array. Great, let's move on. So that's Numpy, and as I mentioned earlier, Numpy is a base library for other libraries such as pandas and also OpenCV, which is an image processing library. So pandas data frames are based on Numpy arrays, and OpenCV objects are based on Numpy arrays. So what pandas does is it just adds some cool features in there, such as it gives capabilities for having table headers and indexes, which you can't have in Numpy, because Numpy is meant to be a more simple and in a more low level of storing objects and doing operations. And so Numpy is a requirement for many libraries. And yeah, let's solve this lecture in here, and in the next lecture we'll go straight ahead and create a Numpy array out of our image in here. So this image. Okay, see you there.